What if everything you see in the night sky is already gone? Not destroyed, but permanently out of reach. The universe is expanding so fast that some galaxies are disappearing forever, and we can prove it. The question is, how did humans figure this out? No one has ever watched the universe grow, no camera recorded its beginning, and yet scientists know without doubt that space itself is expanding, not because of belief, but because the universe left behind clues so precise they couldn't be ignored. For most of human history, we believed the universe was eternal and unchanging. Stars were fixed, the heavens were permanent. Even when we discovered galaxies, many scientists still thought everything existed in a steady, unmoving cosmic structure. This belief survived for centuries, not because it was proven, but because no one had evidence to challenge it. That all changed in the early 20th century when astronomy stopped being about looking and started being about measuring. The person who changed our understanding of reality was an American astronomer named Edwin Hubble. In the 1920s, using one of the most powerful telescopes of his time at Mount Wilson Observatory, Hubble wasn't trying to solve the universe. He was simply asking where galaxies were and how far away they might be. That simple question led to one of the greatest discoveries in science. Hubble proved that many of the fuzzy objects in the sky weren't clouds inside our galaxy. They were entire galaxies of their own, unimaginably far away. Distance alone wasn't the real breakthrough. The true discovery began when scientists stopped just looking at galaxies and started listening to the information hidden inside their light. Light is more than brightness, it's a messenger. It carries clues about motion, speed, and direction across billions of years. When an object moves toward us, its light gets compressed, shifting toward the blue end of the spectrum. When it moves away, that light stretches, sliding toward red. This shift isn't random, it's measurable, it's precise, and it has a name: redshift. When astronomers saw this redshift in nearly every distant galaxy, it was as if the universe itself was speaking, quietly revealing a single, unavoidable truth. Everything out there is moving away. When Hubble studied the light from distant galaxies, he noticed something shocking. Almost every galaxy showed redshift. Almost everything was moving away from us. This alone was strange, but the pattern was even stranger. The farther a galaxy was, the faster it was moving away. This wasn't random motion. These weren't galaxies flying through space. This was space itself expanding. This discovery became known as Hubble's law, and it revealed something deeply unsettling. The universe has no center, no single point where expansion begins. Every galaxy sees every other galaxy moving away from it. From any location, the view is the same. Just like dots on the surface of an inflating balloon, galaxies drift farther apart, not because they're flying through space, but because space itself is stretching. As the universe expands, it carries galaxies with it in every direction at once. No galaxy is special, no position is privileged. Expansion isn't happening somewhere else, it's happening everywhere, all at the same time. If the universe is expanding today, then one unavoidable question follows: when did it begin? Scientists answered this by running the cosmic expansion backward in time. As they did, everything moved closer together: galaxies, stars, matter, and energy, until the universe reached an extreme state that was unimaginably hot and dense. At that moment, space itself was compressed into a single beginning. This event is known as the Big Bang, and it occurred about 13.8 billion years ago. The universe did not explode into empty space. Instead, space itself was born and began expanding, carrying everything with it. But science never relies on a single piece of evidence. There had to be more proof, and there was. In 1965, scientists discovered a faint microwave glow filling the entire universe, coming from every direction. This radiation is called the cosmic microwave background. It is the leftover heat from the early universe, stretched and cooled as space expanded over billions of years. Its exact temperature and pattern match expansion models perfectly. It is the universe remembering its own beginning. So how do we know the universe is expanding? Not because we guessed, but because the universe revealed it to us. When scientists studied distant galaxies, they noticed their light was stretched toward red, a phenomenon called redshift. This showed that galaxies aren't standing still, they're moving away. Even more shocking, the farther a galaxy is, the faster it's escaping, proving this isn't random motion, but a universal pattern. Space itself is stretching, carrying galaxies along and pulling light with it as it travels. And surrounding us in every direction is the faint afterglow of the Big Bang, the cosmic microwave background, cooled and stretched by billions of years of expansion. Every observation, every measurement points to the same undeniable truth: the universe is growing right now. The most astonishing part is that expansion isn't slowing down, it's accelerating, driven by a mysterious force called dark energy, something we still don't fully understand. The universe has a past, a present, and a future that is still unfolding. We know the universe is expanding, not because we guessed, but because the universe showed us, through light, through motion, through time itself. And the deeper we look into space, the further back we look into history, watching the universe grow one photon at a time. If this made you see the universe differently, tap like to support the channel. Subscribe to Space Facts for more true stories hidden in the cosmos. And share this with someone who looks at the night sky and wonders what's really happening out there. Because space isn't just distant, it's still unfolding right now.